Hey guys, so in today's topic, we are going to discuss cogeneration. So, in this chapter of thermal utilities, we are going to discuss cogeneration. So, first of all, we will see what is the need of cogeneration. So, as we know that in India, major source of electricity supply is due to the thermal power plant, which has overall efficiency of around 35 percentage. The rest of the 65 percentage of efficiency is lost. The major source of loss is heat rejected to the surrounding water. This heat rejected to the surrounding water or air due to the inherent constraints of different operating thermodynamic cycle in power plant. Also, 10 to 15 percentage losses are associated with transmission and distribution of the electricity in the electrical grid. So the term cogeneration means the generation of combined forms of energy from primary energy sources. So generation of energy combined form of energy from primary energy sources. So mechanical energy may be used to drive an alternator for producing electricity, while thermal energy can be used either for direct process applications or indirect application. So, what are the advantages of this cogeneration? So, advantages. So, we will see advantages of cogeneration. So, cogeneration is most effective and efficient form of power generation, as it increases efficiency of energy conversion and its use. So its efficiency is very high. Second advantage is cogeneration reduces CO2, NOx, nitrogen oxides and sulfur dioxides to the environment. The third is cogeneration provides large cost savings, providing additional competitiveness for the industrial and commercial users and offering affordable heat for domestic users. Fourth is cogeneration provides an opportunity to move towards decentralized form of electric generation. Decentralized form of electric generation where plants are designed to meet the demands of local consumers, providing high efficiency, avoiding transmission losses, and increasing flexibility of the system use. This will particularly be the case if natural gas is the carrier. Fifth, cogeneration improves local and general electric supply. So it will improve electric supply, which can reduce the risk of consumer being left out without supplies of electricity and or heating. So these are the advantages of cogeneration. Now we will see few applications of cogeneration. So cogeneration can be used. So where it can be used cogeneration. So cogeneration can be used where there is a simultaneous need for heat plus power, that is electrical and thermal. So this electrical and thermal. So where there is need of both, there is a potential for cogeneration. However, significant savings is energy costs can be achieved, and cogeneration system can be more meaningful if the energy consuming facility has the as few as the characteristics. So which characteristics should cogeneration have? First, reliable power requirement. Reliable power requirement. Second, utilization of high thermal energy than electricity. So thermal energy is more required than electricity. Third, quite stable load patterns of thermal energy and electricity. So the load should be stable and not very much fluctuating. Then fourth, long operating hours. So if the operating hours are long. Fifth, the high price of grid electricity or inaccessibility to grid. So if there is a high price of grid electricity or inaccessibility to grid, then you can apply cogeneration. High price or no access. So this are the various conditions where you can find the application of cogeneration. So if reliable power is required, if thermal is more required, loads may be constant for long hours, and if there is a high price of electricity or no accessibility, then you can apply this cogeneration. So some of the application areas where cogeneration has been successfully practiced are, so the areas where it is successfully applied. So we will go one by one. We'll start with industries. So in industries, cogeneration has been applied to food processing, then pharmaceuticals. So in food processing, you may know that a large heat is required even in pharmaceuticals. Third, pulp and paper industry. Then fourth, refineries. Then fifth, fertilizers. Then sixth, even as you know, in it is required in textiles. Then seventh is also required in cement, glass, ceramic, and etc. Many industries you can apply the cogeneration facility, and where in other areas it is used. So other areas where it is used is, we'll start with residential or commercial areas, not industry but residential and commercial areas where it is used. So they are hospitals, then is hotels, and third, commercial buildings. So in these areas the cogeneration is applied. So this was, here we have seen the introduction, the need for cogeneration, because there is a high loss of efficiency in the form of heat. So if we can use that heat directly, then we can save some amount of energy. So we have seen few advantages and we have seen applications of cogeneration, that where it can be required and where it is applied currently, in which industries it has been successfully applied. So now we'll move towards the next topic, that is technologies for cogeneration. So technologies for cogeneration. So, so what are the technologies available for cogeneration? So there are mainly two types of cogeneration technologies. First is topping cycle, and the second is bottoming cycle. These are the main two technologies which are available for cogeneration. So if the mechanical or electric power is produced first, mechanical or electric power is produced first, and the thermal energy exhausted after the power production, thermal energy is exhausted after power production is for thermal energy generation, then this cycle is called topping cycle. So then this cycle is called topping cycle. And if it is reverse, if the high temperature thermal energy is produced first, and then the heat from that energy is recovered as waste heat, and mechanical and electrical energy is produced, then it is known as bottoming cycle. So just there's a difference that here the mechanical electrical power is generated first, and then the waste heat is used as thermal energy power generation is called topping cycle. And if it is reversed, the thermal energy power is produced first, it is used directly, and the remaining heat is produced to convert it to electric power, and it's called bottoming cycle. So now we'll discuss one by one both. So let's start. So we will discuss bottoming cycle. So the primary fuel produces high temperature thermal energy and then rejects the heat. The rejected heat is used to generate power through a recovery boiler and a turbine generator. So bottoming cycles are suitable for manufacturing purposes. So many industries such as cement, steel, ceramic, gas, petrochemical needs thermal energy at very high temperature. So rejected heat is also at a high temperature, having enough energy for generating secondary energy. So this figure will illustrate a bottoming cycle where fuel is burnt in the combustion chamber, then the waste heat. So then the heat moves to the process, and then after process, the waste heat coming out of the furnace, uh, coming out of furnace is utilized in a boiler uh, to generate steam, which generates steam to drive the turbine and produce electricity with the help of generator, and the cogeneration is implemented. So this process enhances the utilization of fuel, and overall efficiency is also increased. The purpose of cogeneration plant performance test is to determine the power output and plant heat rate. So this is the concept of bottoming cycle. Now there is a concept that is micro turbines. So micro turbines, as the name suggests, micro means small, compact, lightweight combustion turbines that typically have powers output up to 330 to 300 kilowatt. A heat exchanger recovers thermal energy from micro turbine exhaust to produce hot water or low pressure steam. And the thermal energy from the heat recovery system can be used for potable water heating, absorption, cooling, descent or dehumidification, space heating, process heating, and other building use. So microturbines can be burn a variety of fuels including natural gas and liquid fuels. So natural gas and liquid fuels. So this is a turbine which is used for cogeneration. So now we will move towards few terminologies uh, or few equations which are required for measuring the performance of overall plant. So overall plant performance, uh, the two parameters used to measure the overall plant performance are heat rate and fuel rate. So what is heat rate? So heat rate is ms into heat of steam minus heat of feed water upon power output. So mass of steam into uh, enthalpy of steam minus enthalpy of feed water, and fuel rate is fuel consumption divided by power output. So these are the two terms which are used for finding the overall plant performance. Then to find the steam turbine performance, uh, we will use the equation of efficiency of turbine. So it is measured in terms of turbine cylinder efficiency, so which is, as we know, the formula of efficiency is output upon input. So that is delta H actual upon, means change in enthalpy actual upon change in enthalpy of isentropic process. So we can get the efficiency of steam turbine. So various parameters are required to be measured using different devices. So for pressure measurement, uh, pressure gauges are required. There is Borden tube pressure gauge as recommended. For power measurement, uh, energy meter can be used. Then for temperature measurement, thermocouple can be used. Then for fuel gas analysis, we can use a zirconium probe oxygen analyzer. Then for flow measurement, uh, we can use volumetric measurements. Then for steam flow measurements, uh, we can use orifice flow meters. So these are the various devices which are uh, used to monitor the various parameters for the for the turbines. So this is the whole terminologies which are required, uh, which you should know, that how we can get the performance of any plant. Now, so how we can improve the performance of this cogeneration plant? So performance improvement. So how we can improve the performance? So we can improve the performance by first recover waste heat from flue gases. Second, recover heat from incinerator of gas. Then third, use waste heat for fuel oil heater, boiler feed water heating, or outside air heating. We can use the waste heat for air heating and other application. Use chiller waste heat to preheat hot water. We can use the chiller waste to preheat hot water. Then use heat pump. Then sixth, use absorption refrigeration. Then seventh, Use thermal wheels. Run around coil systems, heat pipe systems, or air to air exchangers. So which devices we have seen? Heat recovery devices. Heat recovery devices. So these are the few points by which we can improve the performance of any plant. So I hope you understood the cogeneration, uh, the and various advantages and everything. So we will see a new topic in the next lecture. So thank you very much.